Dear students, I am Mahesh Javalkar of Maratha Mandal Polytechnic, and today I am posting my fourth video on DCT question paper 2020 solved. Okay, so today I will take a question number 61 to 80. Okay, so let's start with the first question. Question number 61. This is on ARM controller. So the question says add R0 register, comma R1 register, comma R2 register. Now this instruction perform the following action. Okay. So here in this instruction, that is add R0, comma R1, comma R2. Okay. R1 will be added with R2. The contents of R1 will be added with the contents of R2, and the result will be stored in R0. Okay. So according to that theory, option A will be the right answer. That is R0 is equal to R1 plus R2. Okay. Then we'll go to the next question. Which statement is false for thumb instructions? Okay. Now, as we know, in our ARM controller, we have studied ARM instruction set of 32-bit and thumb instruction set 16-bit. Okay. Now, which statement is false for the thumb instruction features? Okay. So, statement A is separate shift instruction exist. That is true. Option B is all instructions executed unconditionally. That is also true. Option C is MSR and MRS instructions are available. This is wrong because MSR and MRS instructions are not available in thumb. Okay, so here the answer will be option C. MSR and MRS instructions are available. That is a false statement for thumb instructions. So here you can see option C is the answer. Okay. Then we'll go to the next question. The LPC2148 provides dash bytes of static RAM. Okay. Now all these LPC ICs, whatever are there from 2141 till 2148, they will support 8 kilobyte to 40 kilobytes. But if you want to specifically tell about LPC2148, it can provide 32 kilobyte. So option C will be the right answer here. 32K bytes of static RAM will be the right answer. Okay. Then we'll go to the next question. A register used to set the direction of port pin. Okay. Now for ARM controller, the direction of the port pin can be handled by a register IODIR. Okay. So IODIR is the register which can control the direction of port pin. So here option A will be the answer. IODIR. Then we'll go to the next question. Brownout protection circuit is a timing circuit. Okay. Now the option for its working, option A is that prevents the processor from unexpected halt when supply voltage falls below the specified voltage. Option B is that resets the system processor when the program execution hangs up. Option C is that is it resets when supply voltage rises above specific voltage. And option D is it resets when processor temperature rises. Okay. Now from all these options, option A is the right one, that prevents the processor from unexpected halt when the supply voltage falls below the specified voltage. When the supply voltage falls below the specified voltage, it will give an interrupt, it will give a signal, and it will not make your processor unexpectedly halt. It will give an interrupt, it will see to reset, and it will follow with the work. Okay, so here option A will be the right answer. Okay, that it prevents the processor from unexpected halt when supply voltage falls below the specified voltage. Then we'll go to the next question. MSP 430. Okay, this you have studied in embedded system. MSP 430 has dash bit wide data bus and address bus. Okay, so we know that in MSP 430 chip, the data bus and address bus are of 16 bit wide. Okay, so option B will be the right answer here, 16 bit wide. Then we'll go to the next question. MSP 430 has dash number of core instructions. Okay, dash number of core instructions. Clear? Now here, totally instructions what MSP 430 has is 51. Okay, and from that 51, 27 are core instructions and 24 are emulated instructions. So here the answer for core instruction will be 27. So option A will be the right answer. MSP 430 has 27 number of core instructions. Okay. Then we'll go to the next question. Question number 68. Which one of the following instruction is an example of indirect addressing model? Okay. So for MSP 430, which is indirect addressing model. Now here we see that instruction which is given in option B. Okay. Instruction which is given in option B is your indirect addressing model. So here you can see it is add at R5, okay, comma R6. Okay. Now here R5 will act as a memory pointer. R5 will have a memory address. The contents of that address which is there in R5 will go into R6. This will go into R6. Okay. So that is add at R5 comma R6. That means R5 is acting as a memory pointer. Then the address, the number which is there in R5 will act as an address. On that address, what data is there, that will be copied into R6. Okay. So that is what indirect addressing is here. And that is an example of indirect addressing. So answer B will be the answer here. Add at R5, comma R6. Okay. Then we'll go to the next question. In MSP 430, dash register is used to select the direction IO pins. Okay. So here you can have port 1, port 2, port 3, port 4. Okay. Now the first register, that is PXDIR, is used for direction of IO pins. Okay. Now if you want port 1, it will be P1 DIR. If you want port 2, it will be P2 DIR. If you want port 3, it will be P3 DIR. Okay. So as a general thing, PXDIR will be the answer here, which is the register which is used to select the direction of IO pins. So PXDIR is the answer. Then we'll go to the next question. Any hardware at any hardware level can be defined by. Okay. So this is on your VHDL and Verilog concepts. Okay. So this is defined by hardware description language, HDL. Okay. So option B will be the right answer here. Hardware description language, HDL. Okay. Then we'll go to next question. Symbol Z in Verilog, okay, represents what? Symbol Z represents dash in Verilog. Okay. Symbol Z represents high impedance state. High impedance state in Verilog. So option C will be the answer here. If you see the theory here, data types value set. Verilog consists of mainly 4 basic values. All Verilog data types which are used in Verilog store these values. 0 is logic 0 or false condition. 1 is logic 1 or true condition. X is unknown logic value. And Z is high impedance state. Okay. So Z he has asked. So Z is high impedance state. So here symbol Z represents high impedance state in Verilog. Okay. Then we'll go to the next question. The a construct that keeps on executing all times of simulation is called dash construct. This is a Verilog based question. Now the a construct which keeps on executing all times of simulation, that is always construct. Okay. So here option B will be the right answer, which is always. So the a construct that keeps on executing all times of simulation is called always construct. Okay. Then we'll go to the next question. The frequency range for K band in microwave frequency range is, okay, option A is 5.2 to 10.9 gigahertz. Option B is 10.9 to 36 gigahertz. Option C is 36 to 46 gigahertz, and option D is 46 to 56 gigahertz. Now, in these options, a correct range value of K band frequency range is not given. So we have to approximate this range and then we have to mark our answer. Okay. So for this, we'll see a theory. A K band is defined by IEEE is a frequency range from 18 to 27 gigahertz. This is the right frequency range of K band, 18 to 27 gigahertz. Okay. A K band is used in applications like satellite communication, astronomical observations, radars. Okay. K band, which is defined by NATO. NATO has a separate frequency band, and in that, the NATO has defined that this band has a frequency range from 20 to 40 gigahertz. Okay, so you see the original range from 18 to 27 gigahertz. You see the range which is defined by NATO for K band, that is 20 to 40 gigahertz. And then we have to approximate one answer from the four options given. And that answer will be your 10.9 to 36 gigahertz. So option B, we are approximating for K band, because K band basically it is from 18 to 27 gigahertz. Okay, but if you consider K band defined by NATO, which is saying 20 to 40 gigahertz, then we can approximate this option 2 as 10.9 gigahertz to 36 gigahertz. Okay, so this answer is not specific, it is approximated. Okay, then we'll go to the next question. In a transverse magnetic mode, okay, TM mode, okay, the options are: electric field is perpendicular to the direction of wave propagation. Option B is magnetic field is parallel to the direction of wave propagation. Option C is magnetic field is perpendicular to the direction of wave propagation. And option D is electric field and magnetic field both are parallel to the direction of wave propagation. Now, once you say transverse magnetic, that means magnetic field will be perpendicular to the direction of wave propagation and electric field will go along with that direction. Okay, so option C will be the right answer here. So if you see the theory, in a transverse magnetic mode, the magnetic field is transverse to the direction of propagation, while the electric field is normal to the direction of propagation. Now, in this mode of EM wave, the magnetic field is perpendicular to the direction of wave propagation. So, the option C says that magnetic field is perpendicular to the direction of wave propagation. Okay. Then we'll go to the next question. The Doppler frequency shift is given by which equation? Now, if you remember the equation, it will be Doppler frequency Fd is equal to 2 Vr by lambda. Okay. But if you see the statement now, if the target is not stationary, then there will be a change in the frequency of the signal that is transmitted from the radar and that is received by the radar. This effect is called as Doppler effect. So according to the Doppler effect, we get the following two possible cases. The frequency of the received signal will increase when the target moves towards the direction of the radar, and the frequency of the received signal will decrease when the target moves away from the radar. So in such case, your Doppler frequency, that is Fd, can be given as 2 Vr upon lambda, where Fd is equal to Doppler frequency, Vr is the relative velocity, and lambda is the wavelength. Okay, so here option C will be the right answer. Fd is equal to 2 Vr upon lambda. Okay, then we'll go to the next question. Geostationary satellite. Okay, geostationary means it is stationary with respect to earth movement. Satellite in the space is stationary with respect to earth movement. That is, from earth you can always feel that the satellite is at a fixed point. Okay, a geostationary satellite has an inclination of how many degrees? So here the answer will be A, 0 degree. Okay, so here you can see a theory for it. To ensure that a satellite remains over a particular point on the Earth's surface, the orbit must also be circular and have zero inclination. Okay, if we have a satellite in a circular orbit at geosynchronous orbit whose inclination is zero, orbit in the same direction as the Earth's rotation, the satellite appears to be stationary with respect to the Earth over the equator. This is called as geostationary orbit, and the satellite is called as geostationary satellite. So here in this case, the degree of inclination is zero. So answer A will be the right answer, 0 degree. Okay. Then we'll go to the next question. In interactive data communication using satellite, VSAT stands for what? Okay. Now VSAT stands for Very Small Aperture Terminal. That is option B. So here you can see VSAT stands for Very Small Aperture Terminal. It is a small parabolic shaped antenna which is capable of both receiving and sending signals to satellite. VSAT systems can be designed to serve both broadcast and interactive applications, including data, voice, or video. Okay, so here option B will be the right answer. He has just asked the full form of VSAT. It is Very Small Aperture Terminal, right? Then we'll go to the next question. Dash provides intersystem roaming. So this is a question related with mobile communication system. Okay, so Dash provides intersystem roaming. Now here the answer will be ILR. Option C will be the right answer. If you see the theory for that, interworking location register, ILR. ILR offers roaming capabilities between mobile telephony systems complying with different standards. The ILR will make intersystem roaming possible in both directions between all GSM, AMPS, TDMA networks. So the answer will be interworking location register, ILR. So here option C will be the right answer. Then we'll go to the next question. The mobile station, that is MS, moves, that is the mobile phone, okay, which moves from one base station, one cell, to another base station, okay, but same mobile switching center. Then handoff performance is what? Option A is intra-cell handoff. Option B is inter-cell intra-BSC handoff. Option C is inter-BSC because we are having two or more of BSC. Intra-MSC, which is handled by one MSC. That is the right answer. I think C will be the right answer. And D is inter-MSC handoff. This is not the answer. So C will be the right answer. Inter-BSC intra-MSC handoff. Okay. So here you can see there are four scenarios: intra-cell handover within a cell, inter-cell intra-BSC handover where mobile station stays within the control of same BSC. Then we have inter-BSC intra-MSC handover where it is controlled by MSC, perform handovers between cells controlled by different BSCs. This was our answer. Then fourth one, you have inter-MSC handover, which is a handover could be required between two cells belonging to different MSCs. Now both MSCs perform the handover together. Okay. Then we'll go to the next question. So here you can see that the option for this was inter-BSC, intra-MSC handoff. Okay. Then we'll go to the next question. Data entered into the calculator and the result of operation is stored. Okay, so as far as the calculator is concerned, the memory is in terms of register, which is more specific. Okay, so here the answer should be C, registers. So C, registers will be the answer because data entered into the calculator and the result of operation is stored in registers of the calculator, which are acting as memory. Okay, so students, these are the 20 questions what I have taken from question number 61 to 80. Now in my next video, I will take the last 20 questions of your question paper. Okay. Thank you, students.